Okay, my friends. First of all, don't freak out, but we're going to get into atomic theory, chemistry, periodic table, all of the foundations of chemistry and physics, because they're not right. And I'm telling you right now, this you could see this baby's seen some action. This is just a little cheat sheet that I wrote up 50 years ago about what everybody said about Heisenberg and Hund's rule and Schrodinger and Pauli and Aufbau and de Broglie and all these different assumptions that were made about how atoms are constructed, and they're totally wrong. Now, you take hydrogen, right? Everybody knows hydrogen is supposed to be the smallest of the particles, hydrogen, you see it? What they say is the atomic number is 1. What does that mean, atomic number? Atomic number is basically what they consider the number of protons, which are the positive, big, huge things that are in the core that support the number of electrons that circle the core. So you have 1, you have 2, you have 11. So you have you have 2 of these, 4, 10, 11, right? 2, 4, 6 is 10. 2, 2, 4 is 8. 2, 2, 2 is 6. And all the way down the line of all of the different periodic table elements. Now, additionally, they throw in a bunch of neutrons. Don't worry about that. They just don't have any way to account for what they see. Really is basically what it is. And I'm going to show you all of these different principles, and we're going to get down to the Millikan oil drop experiment. I did all this stuff, so don't, I was pretty deep into this stuff. I don't take anybody's word for anything. And that's why I had to, and this goes back 50 years ago. I'm going to show you right now. I could show you positive evidence of what I'm talking about. Since we started doing the light experiment, it all came to fruition. Finally, the things that I knew, but I couldn't prove. Now I think I can prove them, and I'm going to show them to you right now. All right. I know this is going to sound like I am out of my mind, and the reason you're going to say I'm out of my mind is because they know how to put all these different elements together to make different molecules, which are different substances. I absolutely agree with that. However, what they are making and the way they're making it is simply making bigger and bigger snowballs. That's what it is. That's the smallest snowball that they know of, which has 1,837 tiny snowflakes in the nucleus and 1 snowflake trying to get into the nucleus, but the nucleus says, I got enough snowflakes, you stay out. And it says, well, I'm trying to come in. It says, no, you have to stay out. That's the one that's in the orbital trying to get into that. And that's the case in every one of these. Helium has what they say is 2 protons, which means 2 positive, attractive things, because they know there's 2 electrons out here. Well, then they throw in 2 neutrons because they can't figure out what to do with those. Trust me, it's the bigger the snowball in the center gets, the more snowflakes want to come in, because there's a positive and a negative in here, and they never knew this. They thought it was just positive and that was just negative. It never would have worked. They would have that never would have started. Now, so we have a dipole in here. There's positives and negatives, but sometimes there's more positives, which are what they call ions. There's more positives or more negatives. If there is an exact correct number, there'll be an exact correct number of electrons out here, and those are called the noble gases. They are solid, and you can't break them, basically, because they have exactly the right number of electrons, and you can't pull them or take them and give it a shove. All the other ones, where's my chart? All the other ones you can push to shove. These you can't, because they have their full complement of electrons. Everything's wrong in chemistry. Everything's wrong in the atomic world. I'm telling you right now, the nucleus is made out of electrons. We're going to go into that right now. And like I said, I'm not coming across this just guessing. But this is the atomic orbitals, and they keep growing a bigger and bigger and bigger and bigger shell. They show it like an eggshell. Well, I don't think that's actually true anymore. I think it's more of a cloud of electrons surrounding, well, when I say a cloud of electrons, they're a cloud of electron dipoles. And the one side of it wants to get to the dark matter, which is inside the nucleus. Dark matter is attractive. Dark matter is muons. Dark matter is gravity, and dark matter will attract the explosive white particle. And I will show you this. I have shown it. There's no question whatsoever what I'm saying. I can show. So if you can come against me, come against me. That's what I want. Nobody will, because they can't. But they want to stick to their old guns, and their old guns don't fire anymore. Ask your professors about explaining hydrogen isotopes. Well, what's an isotope? An isotope says I'm not really a full, complete particle. I don't have enough electrons in my nucleus. That's what it is. You see this? Hydrogen 1, hydrogen 2, hydrogen 3, 4, 5, 6, 7. All of these different particle sizes and weights, masses, half-lives, how long they stay stable, having those many particles missing or too many particles. You got protium, deuterium, and tritium. There's hydrogen 1, hydrogen 2, hydrogen 3. Now here's what hydrogen is. In electronic flood theory, hydrogen is nothing more than electrons in masses. And hydrogen 1 has 1,837 electrons. But here's how it happens. And I'll show it to you right here. The center core of all atoms is the dark matter. And then surrounding it in a ball is going to be the white matter, the electrons that are attached to it. They are the attractors. The dark matter is the attractor. And I prove this, absolutely. Now watch this. I say that every particle in its atomic raw form, which is every one of these, is a little piece of dark matter, which is the muon, which is the dark matter, and around it is the white matter, which is the attractive explosive. And here it is right here. Boom. You see it? The white matter around the dark matter? And it's in every magnet, and every magnet is exactly the same as every electron. All right, so the electrons act in this manner. They have the white outside interaction, and if you push white against white, which is the outside surrounding this, and you push white against white, it will push against each other. That's push to shove. But white will want to get to that center, so it'll try to come to that center, but this will push it back. The white will push it back. That's what the quantum is. When you have hydrogen, this is like the center, and then you have one little tiny particle way out here that wants to get into the black, just like this. All right? A white one will want to get in to that black, and it will be pushed away, just as this is pushed away. Then you get a hydrogen 2. You get two gigantic chunks in the center, and that will push out two particles, and they will be in exactly a certain pattern. Then you got hydrogen 3, same thing, exact certain pattern. And there'll be 3 of these balls together, which are the 1837 particles. Then you got helium, which has two nucleuses. Well, helium's wrong totally, completely 100% wrong. They got that way wrong. Helium has four which they would call protons, which are 1,837 electrons in these balls, just like a hydrogen 1. But there's 4 of them, and they glue together like this, and then there'll be 4 electrons in the pockets around it. That makes it totally stable. You can't add any, you can't take any away. You take one away, another one will jump in. You push one in, another one will go back out. It doesn't matter. You cannot change that. Can't change that. That's why it is stable. That's why these are stable. There is no extra pockets. These, see here, you know, hydrogen 3, you might be able to force something in. I don't know exactly what. You could break the nucleus a little bit. But these, the stable ones are stable because they have a fulfillment of electrons versus attractors versus pushers. All right, there's no push to shove. All the rest of them have a little bit of push to shove, and if somebody comes in and has a little bit better push, it'll come in. If someone else shoves it a little better, it'll go out. That's just the way it works. And they're different little molecules that come together. And the really reactive ones are way down in here. Carbon, oxygen, nitrogen, boron, lithium. These are very, very, very reactive substances. Then you get into sodium and so forth, where, again, very reactive. Then you get into your transition metals, which don't fit into anywhere, so they throw them in the middle here. And these are the things that go this way or that way, and they give and take molecules as they go through your body to give and take vitamins, minerals, oxygen, carbon dioxide, all that stuff. And they do it with something called ligands. All right, anyway, there's a lot to chemistry now to learn because it's totally wrong at this moment. Everything's wrong. I mean, everything is wrong. I mean, way wrong, everything. Time to start everywhere, right from the start. Every single science. Anything that's been assumed needs a new assumption, or at least to look over the old assumption. Because when you begin by assuming something, you make an ass out of you and me, because you attack me, because you assume before you investigate. Okay, my friends, this is really cool. Now, this is Bruspup, and it is amazing resonance experiments. And what they're doing is they're taking salt, which is nothing more than a polar molecule, NaCl, both sides of the periodic chart, and they're putting it under vibration, which is nothing more than pushing and sucking electrons back and forth. So you're making a positive, negative, which vibrates these positive negatives until you hit a certain frequency, and it has to be exactly that frequency, and bang, they lock in. Then as you increase the frequency, it means them shaking, bang, they lock in again. Bang, they lock in again. What does that tell you? Well, it tells me that because they are magnetic dipoles, you are pushing and sucking electrons back and forth. That's nothing more than a magnetic field. When you do that, the push and shove back and forth will make those little magnetic dipoles, which are just nothing more than little magnets, eventually hit a frequency where they're pushing, shoving, everybody is equal. Everybody likes to be shaken at that rate. You get above that, and it does this, and it goes crazy. Now watch. We're going to go to the smallest particle, way down at 345 hertz. This is very, very, very low frequency. Now watch what happens. Again, Bruspup. Now, there it is right there. Watch, bam, it locks in. Now that's at 345 hertz. This is in my world, this is like helium and hydrogen. It's the smallest of the particles, and it has the smallest region that it can control. Then as your nucleus gets more and more of these electrons, and these are nothing more than the electrons. These are 1837 electrons in a proton. And then there'll be one or such and such rolling around it. And as you get bigger and bigger and bigger, they have to become bigger by chunks of these 1837 at a time. Those are called protons now. But they're still nothing more than electrons. So let's go up to the next frequency. Okay, here she is adding more particles. Now we're going from the first part, where's my, here it is. Now we're going from helium and hydrogen, which was that tiny little place, to the rule of 8. 1, 2, 3, 4, 5, 6, 7, 8. Now we're into the rule of 8, and you'll see that. And all the rest of them follow the rule of 8. The transition metals are in the middle. That's kind of an oddball situation. Here goes the rule of 8, and it's a higher frequency. Now they're up to 10 something, 1033. Look at that. Look at how elegant that is. 1, 2, 3, 4, 5, 6, 7, 8. Those are the electrons that surround the core, and that would be like neon. That would be neon. And then the next one's going to be argon, which is going to be, it's still going to have a rule of 8 around it, but it's going to have more electrons. So let's go a little higher to the next frequency. And so we're at 1033 now, and that was it. Now they're adding more salt because more electrons. Now we're at 1820. Now we have the original layer and then a second layer, and now we have like a third layer. And you're going to see there's going to be 8 of them in here that you can find if you look carefully. Now there's 1, 2, 3, 4, and then 5, 6, 7, 8. That type. I'm not sure exactly how to look at this, to be perfectly honest with you, but it starts to conform to the rule of 8, and you can see them. They become very elegant. You see way out here. Look. 1, 2, 3, 4, 5, 6, 7, 8, and then around on the outside, there's just more and more and more trying to get into that center. Everybody's trying to get into the center, but they're being pushed back. It's push to shove, and that's what these regions are. And in the center is the dark matter. They will always force their darkness into the center, and all of the excited particles will always surround the outside of everything. All right, I can show that in my, and I have, or I believe in my magnet experiments of that shield. Well, here it is right here. Hold on. Somewhere around here. I'll get it later. All right, anyway, and it just keeps getting more and more and more elegant. You see this? And as they get higher and higher and higher up, and then they get into these extremely elegant patterns where they're all trying to get in here. So many that they're just shaking like crazy. Now, what makes them shake? Would they shake in just the real world? I'm shaking them. Well, no, I'm not shaking. They're shaking them on this plate. That's understood. But why are they just shaking? Why would they just sit here all the time shaking? Well, here's the deal. There appears to be some universal frequency of the universe, and I think it's at 428 hertz or something like that, which just continuously vibrates everything in the universe at a certain frequency. It does this all the time. Now, so that's push to shove, push to shove, push to shove, and they stay in these formations. Now, there is something about isotopes, and isotopes means that they don't have exactly the same number of particles as, like hydrogen here on Earth won't have the same number of particles as hydrogen on the moon, or hydrogen on, that type of thing. And it's got to do with the gravity and the frequency and so forth. They really don't understand this. I don't fully understand it either, to be honest. But I can tell you one thing. I do understand that the particles that make up the nucleus of all atoms are thousands and thousands and thousands of times more intricate than what they're talking about. And they end up being these little tiny electrons. Still a dipole. They push to shove to each other until they get into a nice frequency. But you could throw another half a dozen in there or take a half a dozen out, and it'll still be fairly stable. And then they say it has a half-life of this, and then it'll decay to that and so forth. Well, it'll add more electrons, or it'll spit some out. It depends if it has too many or not enough. That's what it's all about. Getting it at the right number. The right number at the right shake, stability. All right, this is Latham's crazy machines. It's exactly what electron flood theory is. It means that the electrons flood the outside, and the dark matter goes to the inside, which is the muons. And that is like you have a negative and a positive. So here's what he's done. They put really it's a positive in the center, and they have all the negatives surrounding it. All right? And it's just how you have the magnet flipped. So these are all one polarity, and this is all the other. So what's going to happen is all the negatives are going to try to get into that positive, which is in the center, but these negatives say no, stay away. So you end up getting quantum, which means they'll come to an exact distance. They see all this happening. They just don't understand the nucleus is a dipole. The core is the dark matter attractor. The surrounding part of the electrons, and it's the dipole part, is always the white part, which pushes everybody else trying to get into their core. So everybody becomes stable at a certain thing. You add heat, which is nothing more than throwing more electrons in, and everything starts shaking. Now you got a problem, because some electrons are being pushed, some are being shoved, some are being sucked away, and some are being pushed off to the side, some are being attached to other molecules, some are being evaporated into the air. You don't have a stability issue. Well, you have a stability issue. It's not stable. Once you start to add electrons, everything changes. And if you really flush it, and that's called heat, you will drive off molecules that will just literally be consumed. All right, now watch what happens here. All right, boom. He's going to take that, he flips it upside down. What you want to remember is that will take on another electron. Light bounces out, but another one just comes right back in for itself. It's all electrons pushing, shoving, bouncing, this and that. However, the cores are resonance frequency designed to be stable at an exact certain quantity of give and take, push to pull electrons. At that exact certain quantity, they become molecules, they become atoms, they become semi-stable. But there's, in between every one of these atoms, there's thousands and thousands of electrons. They thought were just protons. They're not. 1,837 electrons for every proton. So there's a hell of a lot of extra particles they never thought about. And the only reason that biology works the way it works is because there's all these extra electrons. You couldn't possibly do the elegance of life and the chemistry and molecules and all the chemistry we see using this is like a handful of nuts and bolts. We need just so much elegance, and once you get into electron flood theory, you have that elegance. Okay, here's a situation. In the center is a positive magnet. All around it are negative magnets. What's going to happen is any other magnet that comes up is going to be one attracted to the center, but these are negative, and they'll be pushing away. So it will end up coming up to what is called the quantum distance, and here it goes. Now, there's the core, is the positive, surrounded by negatives. Bam, that comes up because, and that is also going to be a core surrounded by negatives. So they come up for these negatives to try to get into that core, and it says, no, you're going to have to stay just as far off because your negatives push away from my negatives. But I know you want to be attracted to me, and I want to be attracted to you, but we can only get so close to each other. That's what quantum is all about. And you can jiggle it around and everything else. Plus, it will stay in between a certain geometry, because everything is going to be in certain relations to each other, the particles. You see that? Now, just to show you what's going on here, you see it shaking, bouncing back and forth? That is the nature of heat moving into things. Extra electrons will flow in. They'll push these in. They'll bounce back and forth. That is the excited state of matter. It's excited state of matter. And but you have to push extra electrons in. Now, they will migrate back out to find a place that will accept them better, which will be a colder place. Heat is electrons. Electrons are magnetic. Electrons are magnetic. They have a positive, they have a negative. Electrons are heat, so electrons are heat, they're magnetism, and we know electrons are electricity. So all three of those are completely related to each other. And I understand them quite well. They flow in, they flow out. When they do that, they create magnetism, they create magnetic fields, they create electricity. Simple as that. And what he's doing here is shaking it back and forth, and they can lose electrons and take electrons in, but they will always come back to where they're supposed to be, depending upon what the core is made out of. And one may go away as electricity, or it might fly away as a set of them as light. Okay, watch what happens. Now he's shaking it. That's heat. That's heat. Heat, 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 heat. Excited, excited. Forcing electrons in. Some of them are bouncing out this way and that way. All of a sudden, light goes flying out.